Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll look at generated data sets. Specifically, we'll look at classification and clustering, regression, manifold learning, and decomposition. So in case of classification and clustering, we can create uh, these spherical blob-like data sets by using the command make underscore blobs. And here is a code snippet for getting that type of data set. Here we can specify the number of centers, number of features, number of samples. In the next case, this is to create make classification data set. So here we have again these are the data set clouds that we see, and in this case we can specify the number of classes, number of features, number of samples, and so on. So as you can notice in this case, the shape of the clouds is not spherical. So here these are isotropic, so they are kind of equal in all directions, and these are sort of random. Next is creating data using Gaussian quantiles. So the command for that is make underscore Gaussian underscore quantiles, and as we can see here, we have this one class in blue, second class in orange, and then we have the another class which is in green color. And another point to note here is that these again are circular data sets similar to the blob data set that we saw in the very first case. Then there is make underscore hasty underscore 10 underscore 2. So this generates data for binary classification, and here is a code snippet for that. Next is a data set to create a data as shown here on the right hand side, which is circular, and for that we can type datasets.make underscore circle, and here we can specify the number of samples. And so we have, in this case, we have two classes that are listed, and this is again shown here in 2D for binary classification. And along those same lines, instead of a complete circle, here we have half moons, half circles. So this is by the command make underscore moons, and if we use this type of uh, this command, then we get this type of data set, which could be useful in training models for a specific type of uh, problem. Then we have a multi-label case. In this, we have a command make underscore multi-label underscore classification. So here we can create uh, a random multi-labeled classification data sets as shown here. There are 4 plots shown. And again, in the command, we can specify number of samples, number of features, number of classes, etc. And here I'm just showing there are 4 classes. So there are these 4 different sets of data that are created. So we have the y values. There are 4 different y values for the same 2 features. So what I've done here is plotted those y values with different colors in each of these 4 plots for the same feature data points. So as you can see, these are orange, and when the for a particular set of y values, and then this then becomes blue for another set of y values. And for biclustering, there is this command which is make underscore biclusters, and it gives an uh, array with uh, blocks along the diagonal of a matrix as shown in this particular case, and the command for that is shown here on the left hand side. Similar to the biclusters, there is something called as make underscore checkerboard, and this again creates a block checkerboard type data set for biclustering. And this is the command for that, make underscore checkerboard. Now let's look at generators for regression. And here we have this very first example, similar to make underscore classification. Now we have make underscore regression, and we can specify the number of features. So this is just one feature and one target, and these are the data points. You can specify a number of targets, add noise, and also add uninformative uh, values in there. And the number of features again is here, and we have a number of samples. So how many records do you need in the data set? Next, we have make sparse uncorrelated. So what this does is it creates a data set for regression problem as shown here, uh, which is sparse uncorrelated design. And this is the command for that, make underscore sparse underscore correlated. You can specify a number of samples, number of features, and here I've specified 5 samples. So we have 5 rows and 4 features. So 4 features, and these are the corresponding y values for those. Now for in regression, we can also create the make underscore Friedman 1, 2, and 3 types of data. So the very first one that we are seeing here is the Friedman 1, and that data set is created based on this particular equation that's shown um, at the bottom of the slide. And the data set looks something like this, shown in the right hand side plot. So if there are say 5 features specified, then the distribution would look like this. And in Friedman 2, the equation from which is used to generate the data changes, and we get these kind of blocks. So features 0 and 1 are from this range to here, and then uh, so they are kind of stacked horizontally. So we have 0 to 1 is feature 2, then 1 to 11 looks like it's feature 3, and then from there onwards this is feature 0, and then after that there's feature 1. So if you plot all of these together, this is how the plot looks like, and it's more or less uniform distribution there. And the Friedman 3, the equation is different, and I tried plotting this, and the plots look kind of identical with what we saw in the previous slide. So looks like we with those settings we may get a similar data set with make underscore Friedman 3. Now for in manifold learning, we can create these types of data sets. First one is make underscore s underscore curve. So this is S shaped data set. As we can see, there is a S on the right hand side plot, and the command for that is code for that is on the left hand side, as we can see here. And this returns 3 features when we create this particular data set. Similar to this, there is a make underscore Swiss roll data set, and it creates this data set which looks like a Swiss roll. If you have seen one, it's you basically have this wrapping, and inside that there will be the stuffing for the Swiss roll. So similar concept here to create this data set, and the code for that is the left hand side, make underscore Swiss underscore roll. And I will be using these data sets in the upcoming unsupervised learning videos, where generally what the idea is that if there is a point right here and if there is a point right here, then if we calculate the Euclidean distance, the straight distance, it may not be representative of what the uh, uh, actual uh, uh, grouping the inside that particular data is. So what we would be doing then is calculating this distance along the curve of this um, data right up to that point. So that tells us that this point is farther from that point, and so on. So So that's where we'll be using the manifold dataset to train on a manifold. Now for decomposition, there are a couple of ways we can create the dataset. The first is uh, using this command right here, make underscore low underscore rank underscore matrix, and it creates these data sets. The histogram is on the left hand side, and here on the right hand side I've plotted the feature 1 against 2, and we can see a spherical shape. So that's the uh, make low rank matrix. The next one is make sparse coded signal, and this is we have seen this in one of our earlier videos where we can create this sparse signal as shown here on the right hand side by using this code shown here on the left hand side. So the code would be make underscore sparse underscore coded underscore signal. Then we have make SPD matrix, so a symmetric positive definite matrix, and here this is the code for that, and this is the example matrix created. And to check if that's positive definite, we can look at the eigenvalues by this typing this command np.linearalgebra.eigenvals for x, which this would be the x in this case, and we see that all of them are greater than 0. And similar to this, there is another command which is creating a sparse symmetric definite positive matrix. So make underscore sparse underscore SPD underscore matrix, and that is shown right here. Again, we can check the eigenvalues are positive. So that was it for this video. I hope in this video you got an intuition about how we can generate data sets using the methods that we have in Scikit-learn, and these are especially useful and helpful when we are trying to learn as to the peculiarities of each of the methods, either in supervised learning or unsupervised learning. And so we can create custom data sets to check if a particular method works well on that type of data set, or if a particular method is suitable for a specific uh, arrangement of data points in that particular data set. In next video, we'll look at yet another example of uh, what Scikit-learn has to offer for data sets. Until then, please like, share, and subscribe. I hope to see you all in the next video. Thank you.